Okay, here we go. We are in the next part of our lesson about pure substances and mixtures. And so this section is called Great Combinations. And we are going to be looking at physical changes of matter. In the last unit, 1A, we learned that physical changes occurred when the substance did not change its chemical properties or characteristics. So if I take a piece of paper and I crumbled it up, it was still a piece of paper. Now we're going to kind of zoom in and look at the molecular level. So on your gizmo yesterday, you played around with building elements. And so atoms are the smallest unit of an element, and all an element really is a whole bunch of the same thing hanging out. But those atoms have distinct characteristics and react differently than other atoms. You learned that inside the nucleus there are protons and neutrons, and that you have electrons that are orbiting outside of the atom. And they're held close to the atom by the attraction between the positiveness of the protons and the negativeness of the electrons. And so it's kind of like a magnet. If the electrons get too far away, then that attraction isn't strong enough to hold the electron on the atom. If there's a lot of positiveness in the atom, then that atom can steal an electron from somebody else. So there are a lot of fun stuff that happens with these electrons. So here we have carbon. We are carbon-based life forms. Carbon is a very special element in that it can make 4 bonds, and it makes very strong bonds with other elements and can make a variety of things. This 4 bonding thing is very important to us because it's the backbone of our carbohydrates, our proteins, our DNA, and our RNA. So we have a lot of carbon. There is a lot of people that speculate that if we ever do find alien life, that it might be silicon-based. Silicon has 4 bonds also, but they doesn't make quite as strong covalent bonds as the carbon atom does. So carbon atom is special to life, special to us. And so it has 6 protons and 6 neutrons in the nucleus, has 2 electrons in the first shell and 4 in the outer shell. Remember from the gizmo that you learned that the first shell always carries 2 electrons. All the shells after that are going to carry 8. We aren't going to go and do crazy orbitals. Save that for chemistry when you get into high school. And so we're going to go with 2 in the first shell and 8 in all the other following shells. So carbon has an incomplete outer shell. The outer shell is called the valence electrons. It's the valence ring because those are the electrons that are going to be doing the reacting. So carbon needs 4 electrons, or it needs to bond with 4 other things to have 8 in its outer shell. Atoms, we try to understand them by making molecular models. And so this is a model of caffeine. There are standard colors for certain atoms. And so in chemistry, if you're a chemist, you are going to do a lot of building of molecular models. Nowadays, we use computers, but before we used those little round balls with the sticks that you put together. And I'll try to dig some of those out. But molecules and compounds can get very complex very quickly. And so when atoms combine together, they take on different characteristics and they will react differently than if they were all by themselves. A mixture. In a mixture, there's no chemical combination. So here we have sprinkles and pudding, it looks like. So we mix that up and we have pudding and sprinkles. They're not chemically combined. So we would call it heterogeneous. Now, eventually, of course, if we let the pudding sit, then the sprinkles are going to melt, and that's a whole different story. But a mixture are things that are not chemically combined. So number 5 here asks you to compare and contrast elements, compounds, and mixtures. And so take a moment there and answer number 5. What I would probably start out doing was make myself a chart of elements, compounds, and mixtures, putting how they're different, and then trying to figure out how they're the same. So take a moment, answer the question, and come back to the video when you're ready. The next question asks you to predict. You see these words here in these questions like predict and analyze and identify. Those are all based on the 5 E's of education. It's a way of exploring scientifically the phenomenon that we're investigating. So it asks you to think about if you've ever baked a cake or bread. You know that when the ingredients combined and you taste them, bake them, and then you taste them, they're different from the raw batter that you started out with. And so they want you to take a step back and think about, why do you think that is? Why do cookies taste different than the cookie batter? I don't think anyone's ever really taken bread dough and tasted it, but it definitely tastes different after it bakes. Then you have a visualize question, and it asks you to analyze. Why are the spears representing nitrogen, oxygen different colors? And take a minute, give that a thought, and fill it in. This is a very complex molecular model. This is actually DNA. And you see you have the different colors for the different atoms or the different elements. And so when chemists work these out, they actually can measure the angles and the distance between all these atoms. So it's not them just throwing them together. There's actually very specific angles and rules that they have to follow. So they didn't just dream up what DNA looked like. They have scientific data to know that these fit into a circle and that this red one is this far away from this white one. And that's it for that section.